I wrote parallel. I no, nobody got marked down.
I don't think you guys did the same thing.
It's parallel if they're scalable.
All right, how's it going? Going good. So like 5 or 6 people have already turned in PA2, which is cool. So it's a thing. So hopefully you're making good progress on PA2. Right on top of it. I know about your progress. All right, so any questions? Yeah.
Where did you get your shirt? I like that.
Kohl's, thank you. Yeah, Rockin' Republic. That was an easy question. Any other questions? All right, well, so got some things to go over in no particular order. I'd like to talk about arrays. And you don't really need arrays for PA2, but you may start messing with them for some of the suggested steps I had. And they'll come up eventually anyway. So let me talk about arrays in Java, because there's a bit of a trick to them. And then I'm going to finally talk about class extensions. And then we'll probably go back into IntelliJ and play around with some more graphical stuff. And then next week we'll get into graphics for real. And go off the deep end.
Can I ask a question while still?
Absolutely.
Brain. Will you be doing the walkout next Wednesday? Will you be here?
Is that like officially a thing now?
My history teacher said that she would not be there on Wednesday.
Okay. I am planning to be here, so. Unless something compelling happens that changes my mind, yeah, I'm planning to.
How can we compel you?
Well, I mean, you're paying money for, in one way or another, you're paying money for coming to class and having me talk, so. All right, so let's make a main class. All right, so we've sort of talked about arrays informally. We can declare an array by just saying integer or data type, variable name, bracket, bracket. That says this is going to be an array. That is in some sense, but not exactly. In some sense, that's kind of like when we used to do this. So when you say integer star I, you're saying I is a pointer to an integer. I is basically an array of integers. But if we try to say, give me the value of I bracket 0, we're going to get a seg fault, right? Over here, when we say integer I bracket bracket, we're saying I is going to be an array of integers. But if we do something like this, try to use element 0, right? It'll complain to us that I has not been initialized, which is kind of saying you would get a seg fault if I actually ran this. So in C, what do? We say I equals malloc 10 times size of integer. Over here we say I equals new int bracket 10. So that's a declaration, that first line. This is actually constructing an array of integers. And now we can get away with that compilation, and the execution is fine. And we've allocated space for 10 integers, so if we try to access element 20, we'll get an out-of-bounds exception. And in fact, if we try to access element 10, we'll get an out-of-bounds exception because you only have elements 0 through 9. But element 9 is fine. So that's all you need for creating arrays of integers, doubles, floats, characters, booleans, these so-called primitives, right? So the lowercase types of variables. It's different though if you're creating an array of objects, like uppercase integers or fractions or rectangles. So let's make a rectangle class. So a very uninteresting class, it just holds a height and a width. So let's make an array of rectangles. And we'll construct new rectangle bracket 10, so that actually creates the array. And now let's do something like I bracket 9 dot height equals 5, and I bracket 9 dot width equals 7. Compiles fine, gives us a null pointer exception when we run, basically a seg fault. And the problem here is that rectangle is an object, so we kind of need to talk about pointers to rectangles. And basically we need another malloc somewhere. So the analogy to C kind of breaks down, so let's just do this as Java. So I equals new rectangle bracket 10. So now I is a thing, it's an array that has space for 10 rectangles. But those rectangles themselves don't exist. This is creating the array, right? It's an array of, if you will, pointers to rectangles, but those pointers themselves haven't been initialized. Yeah?
If rectangle takes 8 bytes, then when you say rect I equals new rect 10, is that allocating 80 bytes?
It would be, yeah. But don't think of it too much as doing like a malloc. It's not exactly the same thing. But yeah, it does have to allocate memory, and it would pick up however much memory it needs times 10. Possibly more. Alright, so this declares an array, doesn't actually grab any memory. This sets up memory for 10 references to rectangles, but it doesn't actually create any rectangles. So if I try to use rectangle bracket something, that value is null. So before I can actually use rectangle 9, I need to do the following. I bracket 9 equals new rectangle. Paren. So now this 9th entry, which happens to be down here, now this actually has a rectangle in it.
So even though you already allocated, or not really allocated, whatever, even though you made that spot, you still have to declare it as a new rectangle?
Yeah, because we've made that spot, and what's in that spot right now, null. Right? Just like when you say rectangle blah, blah is a rectangle, but its value is null. So this actually constructs a rectangle, and then we can deal with its height and width. Yeah?
Can you combine the first two lines where you can say rect I square brackets equals new rect
Yep.
10? Okay. So just like a regular declaration.
Yeah. So that compiles, that runs. And it's probably the easiest mistake to make in Java when you're dealing with objects is set up an array, go ahead and do the new rect bracket 10, and then forget to initialize the individual elements. And if you start getting these null pointer exceptions and you've got arrays, that's probably what's going on.
Is it possible to initialize the individual elements as something other than a rectangle if it's the correct size?
I think it's going to insist on it being a rectangle because it's an array of rectangles. The compiler gets all in your business. Does that seem weird?
Well, yeah, because you have to initialize each element, but like as a rectangle. But you allocate it. I don't know. It's weird.
Seems like you're telling it twice.
Yeah.
Yeah. But the thing is,
You just throw that in the loop to allocate the whole thing.
yeah, you can throw it in a loop to set all that up. But suppose there's no default constructor. Suppose your rectangle requires that you construct it by giving it a height and a width. And there's no sort of default constructor. So that's invalid, right? If this were enough to actually construct the 10 rectangles, what values would you have it pass to the constructor? Because constructing an object is not, it can mean many different things. It can mean just grabbing some memory so that you have enough space for all the stuff that goes in that object. Or it could mean, reading standard in and breaking up your input into text and building a linked list of linked lists, which would be a different version of PA2. And it might depend on how you construct. You construct with no arguments, one argument, two arguments, etc. And so there's no way that in general the compiler could decide what to do as far as actually constructing those objects to fill in the elements of the array. So I think that's the reason, one of the reasons you have to do it explicitly. Is there another hand? Did everybody sign in, or should I send this around again? Or come up afterwards and sign it? All right, so arrays of objects, we always have this kind of two-part construction. We use new to construct the array itself, but then you have to use new to construct the actual elements. All right, so that'll construct all elements of the array. And then we can tinker with them individually. All right, good on that. Like I say, that's not something you necessarily need for PA2, but sooner or later you're going to want to have arrays of objects. All right, we have our rectangle class. It's got an area method now. It's got a perimeter method. It's got a glaring lack of comments. But that's a rectangle class. Don't worry about main. Gotta return an integer. Alright, suppose we're going through life, we're using our rectangle class, everything is great, everything is perfect, and one day we decide, you know, I really like squares. I wish there was a square class that did everything the rectangle class does, but specifically for squares. And yeah, I can construct a rectangle and just make the length, height, and width the same value, but I don't feel like doing that. I want a square class. So I could, you know, download the source code for rectangle and modify it to make my square class, or I could write it myself, I suppose. But if I'm really lazy, like good programmers should be, I know that the rectangle class almost does everything that I want my square class to do. Right? It's just that I want the height and width to be the same. So here's what I can do. I can make a square.java, and I can define a class square, and I can say this extends the class rectangle. And extends is a powerful keyword that basically says my square class is going to look almost exactly like my rectangle class, but I'm going to add some extra stuff. Or maybe I'm going to change some stuff.
Can you take away stuff?
No, but you can overwrite stuff, which is almost as good.
This is just creating a child class, right?
It's basically creating a child class, yeah.
So if you are using an extender and you make a new constructor, does it overwrite the constructor that's already in the class?
Yeah, so constructors are the weird part about extensions. But yeah, if I write a constructor in here, it's going to take precedence. So let's do that. All right, so I'm going to define a constructor. It's got to be an uppercase S. And it's going to take one argument, which is the length of a side. What I'd like to do is call rectangles constructor with side as both the height and the width.
Can you do double child, like dual parent inheritance in Java, or is it
I don't think so. Yeah. There's other mechanisms you can use to fake that. All right, so there's another keyword, which is super. Super is a way to get to something in the base class or the parent class. So square is the class that we're defining. Rect we can think of as the super class. Okay, this is a subclass of rect. Rect is a super class of square, so it's a hierarchy. So if I want to get to something in the rectangle class, I can use this super keyword. And it's kind of like this, but instead of referring to me, it's referring to the thing that I'm extending. So 75% chance this is going to work. What I'd like to do is call a superclass's constructor with 2 arguments. Let's see if that works. Wow, that worked. Okay, so let's try this.
What was your fear that it wouldn't work?
Black hole opens up in the parking lot. Yeah. Fear was that I don't know. There's just lots of special rules about constructors, and it would say like can't access constructor like this.
Gotcha.
So square s equals new square 5. All right, so we construct a new square and we'll print out the area and the perimeter. I thought something looked funny there. Thank you. Our print line. All right, compile run works perfectly. So look at this. This is like, you know, a few lines of Java code that I wrote, and my square now has a perimeter method, and it's got an area method, and it's got a height and a width, and anything else that was available in the rectangle class is available here.
So what's the benefit of doing an extension rather than changing it?
If you have access to the original code and you want to copy and paste and make a new version, you can do that. But if you don't have access to the original code, right, this is your best bet. And this is going to come into play when we're doing graphics, because we're going to use J panels and J buttons, some of these things we started to look at yesterday. These have all kinds of features and capabilities, but they don't always do exactly what we want. For example, when you display a J panel, you get a solid background, you get a border around the outside, you get some buttons in the corner, and that's it. What if you want your J panel to display a bunch of rocks floating around and a little ship in the middle that you can turn around and shoot, and little dots come out and hit the rocks and split them in half? Right? That's not what a J panel does. But a J panel does a lot of other nice things. You can grab a corner and resize it. You can cover it up with another window, and when you take the window away, it refreshes what was there. It's got a maximize button and a close button and a title bar and all this other stuff. And I don't want to write all that stuff every time I want to make a display. I just want to add something to this. I want to display a sine wave that wiggles around or something. So I would like to extend the JPanel class and make my own class called myJPanel maybe, that will do all that stuff, but also do one or two other things like play asteroids. And so it's going to be easiest to just define an extension of a JPanel. So we'll use extensions a lot, in particular for doing graphics. Anybody been messing with IntelliJ and widgets? All right, let's mess with it here. Anybody figure out why it's called IDEA? I Googled a little, I couldn't find a quick answer. No idea. It's not calculus, it's a calculator. All right, so I'm going to come down to the source folder, I'm going to right click, and I'm going to do new dialog. And I'm just going to call it main, and we're not going to have OK and cancel buttons. And I'm going to go to the form, and I'm going to delete all this stuff. Alright, so there's an empty J panel. Let's make a simple calculator, just to play around with this idea of event-driven programming. And I don't want to make a bunch of buttons, so this will be a binary calculator. Put things in 0 and 1 buttons. So I'm going to put a couple of buttons over here. And this first button I'm going to call button 0, because that's going to be my 0 button. I'm going to change the text to 0. And this button I'm going to change the text to 1. I'm going to call this button 1. And I'm going to put a display area up here. which I'm going to call answer. I'm going to put a 0 in there. And let's see what we got so far. Alright, so not very exciting. Our buttons don't do anything. So what do we want to have happen when we press the 1 button? We want a 1 to show up, and what if we press the 1 button again? So here's our answer. And we're just going to display this in binary for now. So here's a 0 and here's a 1. So when you have a regular calculator and you start typing buttons, what does that do to the display? It starts displaying the buttons left to right or right to left. I had to pull out a calculator to figure this out. So it's right to left. Each button that you press appears right going down in that direction. I think.
No, that's left or right. That's left or right. We said right or left.
So
So when the first number you put in, it assumes it's the lowest priority. And when you press the second one, it scoots that over and it enters from the left.
so your numbers go like that? Really?
On some calculators.
Yeah.
Wait, doesn't it depend on the calculator?
Probably.
I don't know.
Phone calculators go from.
I only use my phone calculator.
Well, yeah, right to left.
Okay, so we're gonna add things over here to the left. Okay, that works for me.
I think it
All right, so let's do something when we press the 0 button. So go back to the form. Let's right-click on the 0. Let's say Create Listener. We'll add an action listener, and let's put some code here to add a 0 to the display. So I'm going to punt to a method called add character that's going to say add character 0. And over here on the 1 button, we're going to create a listener, action listener, and our action here is going to be add character 1. All right, why am I putting this in an add character? Because it's going to be almost the same code, and I don't feel like writing it twice. And if we get it backwards and we want to change it, I don't want to change it in 2 different places. So let's make our add character method. Alright, so I'm going to pass it a string, and it's going to add it to the display. Well, whatever the display is right now, we need to figure that out, and then we need to stick our new character to the left, right? Correct. So what is this thing called answer? It's a Jlabel. And Jlabel is part of swing, so look up Jlabel. We got stuff running now. This, by the way, this shows the extensions. Jlabel is an extension of JComponent, which is an extension of a container, extension of an AWT component, and an extension of an object. So you can extend something, and then you can extend that as another class. So Jlabel has a method called getText. Return the text string that the label displays. and has another method called setText, which takes a string and causes that to be displayed in the label. So to add this characters to the string, we could do something like, what's our answer called? Answer.setText C plus answer.getText. So what's that? We're saying read the text that's in the label right now, append the string C to the left of it, and now set the label's text to be this new string. And that's all it takes. So as I start hitting buttons, they start appending to the left. And they do that forever. And we don't have a delete button.
What's gonna happen? No, keep going. Let's see what
I'm
happens.
going to go off the edge of the screen. Yeah. I'm curious how hard it is to change the font. I might have opened a can of worms. There we go. Alright, that's better. Of course my buttons are growing too, which is a little weird, right?
Yeah.
So that's the window manager kicking in. And there's ways to deal with that. Bless you. Alright, so what do we want to do with this? Let's make it look a little more like a calculator. So there's a problem here. If we want to actually enter the number 1, we can't, because as soon as I hit a 1, I get the number 10. So calculators have this weird thing that you may not have noticed. The first button that you press actually replaces the 0, and then the next buttons start getting added to what you've already got displayed. So how the heck would we implement that kind of behavior? So that the first button we press actually takes the place of the 0, and then subsequent buttons get added. Yeah?
The answer string is just 0, then just replace it.
That's what I was going to suggest. But there's one problem with that. What if we actually want the first digit to be 0?
So if the string is 0 and the input is not 0, replace.
That might work also. What was your idea?
I was going to say use just something along the lines of like 0 as a sentinel. And just like from there, your next location.
Interesting. That could work too.
You could probably, if you stored it as a number, and then you just printed a representation, then you could have a null that gets mapped to a 0.
Okay, that could work too. These are good ideas. Any other ideas?
Could use a flag.
Could use a flag.
The first time you press it, it has 1.
All right, I'm going to go with the flag. Because the flag means that we're paying attention to state. And the more we do event programming, the more we want to start thinking about the state of our code. Because in general, you got a few buttons, and different things may happen when you press these buttons depending on what's happened before. Right, for example, in our tic-tac-toe game that we're going to talk about next Friday, if you click in the upper left corner, a number of things may happen. It may display an X if you're player X. It may display an O if you're player O. It may yell at you if somebody else has already moved in that square and say, you can't go here, somebody's already in this spot. It may yell at you if the game is over already and you're trying to make more moves, right? It's the same button. It's going to call the same listener, the same set of code, but what happens in that code is going to depend on the current context of the game, of the program, right? So we're always going to be thinking about state. And this is, state machines from 250, right? It's exactly the same thing. You've got some inputs coming in, but what actually happens inside the machine depends not just on the inputs, but on your current state. That's a Turing machine. Current input, current state causes some new output and some new state, right? That's what a computer is. So let's make a flag. So I'll make a private Boolean, first number equals true. And now in my add character method, if first character, it's apparently not what I called it, first number, then we'll just go ahead and make our number equal to whatever the user put in. Otherwise, we'll go ahead and we'll append.
Don't you want us set to first number to false? Is that true?
Oh yeah, because now we can only put in one digit at a time. Alright, so now I can enter 1, 0, 0, or I can do 0, 0, 1. There's the easy way to keep the buttons from growing. Just make them big to begin with. All right, what if we want to convert this to decimal? Say again?
Oh, I thought you meant more numbers.
Oh, no. Yeah, we could add more buttons and have this have a 10-button calculator. What if we want to take the number, the 1 and 0 number that we're displaying, and also display it in decimal? So let's make another Jlabel, and I'm going to call this decimal out, and I'll initialize the text to 0. And where's the font? I'll set the font size to 26 also. So what do we have to do to put the decimal equivalent of that other number in this window? How do we convert from binary to decimal, first of all?
Take the position of it's in and then square, then square, right? No.
Sort of. So powers of 2?
Yeah.
Right, weighted positional notation. So we could do it by hand by taking that digit, multiplying by powers of 2 and adding up.
There's probably a Java class already for that.
There's probably a Java class already for that. There is, and it's in the integer class. And it's called parseInt. And parseInt normally takes a string, converts it to decimal, but if you give it a second integer, which is the radix, it'll convert from that radix to an integer. And so we can use that. So where are we going to do this conversion? We're going to say integer.parseInt answer.getText, comma 2, but where should we do this? Right, event driven. Because our program doesn't really have a loop. It's not like we can put this inside a while loop. We're really just jumping into some code when a button gets pressed, and we're not really doing anything other than that. Yeah.
You could create a method to update the text and then call that when we add a character.
Okay. Create a method to update the text and call that when we add a character. So let's convert the binary display to decimal. So void update decimal. I never remember what I call my. Didn't we give that a name? Decimal out. So decimal out dot set text integer dot parse int answer dot get text comma 2.
Is the comma 2 necessary?
Because we want base 2. Otherwise it would read it as, 1001.
Okay.
And so what's going on in here? We're saying let's get the text from the answer box. That's a string of ones and zeros. We're saying parse that as an integer base 2. So all of this is giving us back an integer. And then we're saying set the text to that, but we can't set text to an integer. We won't need to set text to a string. This is our old problem. So we can just concatenate it to an empty string.
So could we set any base for that?
Yeah. Up to apparently 36. All right, that's a really, really powerhouse statement right there. All right, there's like multiple function calls and things happening inside the argument lists. And that's a one-line method that'll update the decimal display based on what's in the answer display. So we need to do this anytime the answer display changes, which is going to happen only right now in our add character routine. So after we've done one of these two updates to answers text, we'll go ahead and say update our decimal display. I could do it in both the if and the else statement, but I'm just going to put it outside. So we'll run this. There's our binary, there's our decimal. Here's a 1, there's 3, there's 7, there's 4, still 7, there's 39, and so on. Arguably useful, but hopefully interesting. And this is not a lot of code. Right? We put in 2 calls to add character, we wrote add character, we wrote update deck, that's it. And we've already got stuff happening. Why don't you go negative? There we go. Alright, so what's all of this stuff going on down here? Number format exception, so our string is too big. And take a look at this call frame. So AWT wait dispatch support $2.run, whatever that is, right? That's something that was basically waiting for events to occur. And when we clicked, right, and when we released, this basic button listener mouse released method fired, and line 252 in that made a call to action performed, which was our line 27 in our main.java. So now we're inside our code, right? So that's this line right here, which said add character 1, which called line 41, which said update decimal, and inside update decimal we said set text, and it was when we were trying to do the parse int, so line 583 of the integer class, and at that point we got this number format exception. And then the exception handler printed out the details of the message, of the error. So what do we do about this? Because we can't sell our software and have it giving messages like that. So how do we avoid those messages?
Put that in the try catch.
Put it in a try catch, absolutely. Right? We could try to figure out when this error is going to happen, and we could count how many bits we have in there and so on, but this is a really good application for a try catch. Because we understand that an error might occur, but it's hard to predict where it does, and if we just put that in the try catch, our catch block could do something like change it to a 0 or change it to infinity or something. Or ideally, before we add this character, well, we could return a flag from here saying did we succeed in updating or not. And if we get an error, our catch block could just say return false. And then in here, when we do our update decimal, we could do that tentatively, right? And if we get an error, we could roll back the input, so we would basically refuse any keystrokes that would cause an overflow. So there's lots of options. But again, this is where I just say it's just programming at this point, right? Whatever you want to do, whatever makes sense for your application, you just write the code to take that response. All right, so Monday we will start looking at graphics, and I want to look at sort of how graphics come to be, how do we draw lines, things like that. And I want to look at the graphics class and see how we can start making some things happen on these JPanels.